Okay, let's take a look at problem 4.37. Two adults and a child want to push a wheeled cart in the direction shown in direction marked X as figure 4.36. That's to the right. Okay, the two adults push with horizontal forces F1 and F2 as shown in the figure. They're not completely horizontal, you can see that. They should find the magnitude and direction of the smallest force that the child should exert. You can ignore the effects of friction. Okay, so let's start with that. Okay. In order to do that, we have to take each of those two forces and figure out what the amount of each one in the horizontal and the vertical direction is. You can see the first force is 100 newtons and it's at an angle of 60 degrees to the horizontal. So first let's break that apart. So we're going to do part A here. We've got a force here. It's 100 newtons. And it's at, okay, I'll try that again, maybe, okay, and it's at an angle of 60 degrees. So to find the parts of that one, F1x is going to be 100 newtons times the cosine of 60. That's going to be 50 newtons. F1y is going to be 100 newtons times the sine of 60 degrees, which is going to be 87.7 newtons, because it's just going to be root 3 over 2. Okay. And then we're going to have to do the same thing with F2 over here. It's going to be downward like this. Notice I left both of them as positive, or I should mark both of them as positive. Okay, because they're both going to be upward, and that's going to be important to us. Okay, this one here, 30 degrees, and it's 140 newtons. So we're going to be able to figure out what those pieces are too. Okay, so F2x is going to be 140 newtons times the cosine of 30 degrees, and that's going to be 40 cosine 30. I got 121.2. And F2y, I'm going to mark that as negative right away because I know it's downward. That's 140 newtons times the sine of 30 degrees. I know that's a half, so it's going to be negative 70 newtons. So it looks like both the other forces, the X force, the 50, and the 121.2, those forces are going to make it go in that positive X direction. But I only want it to go in the X direction. I want to constrain it. So the Y forces have to add to 0. The sum of Y has to be 0, which means that, in this case, 50 minus 70, oh, I lied. It's erase that. Should be 87.7, because that's the Y force, minus 70 plus whatever that third force that the kid puts in. That's going to be 0. Okay. So it's going to be 17.7 minus the kid. It's going to be 0. Well, the force of the kid has to be negative 17.7 newtons. Okay. Or you can call it 17.7 newtons downward if you like, or if you'd like to call it 17.7 newtons, 90 degrees in negative y, whatever you like. Either way, that's going to get you the answer to that part. Okay, so if we're we're looking at the second part. It says, if the child exerts the minimum force found in part A, the child accelerates at 2 meters per second in the 2 meters per second in the negative x or positive x direction. What's the weight of the cart? Well, what that means for us is that we have to take those, since there's no y forces now, they all add to 0. That's what we found in part A. Then we're just going to have x forces. And the x force for the first one was 50 newtons. And from the second one, the x component is 121.2 newtons. Okay. So we're able to get both of those, which means we know what the total force is. We can add those together. The sum of the x forces is going to be 171.2 newtons. And they tell us the acceleration, so we can use Newton's second law for this one. We're going to say, so F sum of forces equals ma. Okay. So 171.2 newtons, that is equals the mass, which we don't know. It's going to help us find the weight, times 2. Divide both sides by 2, you get the mass is something close to 85. 85.1. 85.1, and that's kilograms, because this is meters per second squared over here. A Newton divided by meters per second squared is going to give us a kilogram, remember? And then if I want to find the weight, that's the force of gravity. That's going to be mass times the acceleration due to gravity. That's going to be 85 kilograms times 9.8 meters per second squared. Multiply those together, 85.1 actually, times 9.8. You get, I have 833.98. Try that again just to make sure I agree with myself. 833.98 is right. So 834 newtons. I think I wrote in the actual key, I wrote like 840. I think it just depends on how the rounding goes. So that'll do it for 4.37.